Keeping on with our final exam review, let's find the slope and the y-intercept of the line 3x minus 4y equals 12. So in order to find the slope and the y-intercept, I'm going to want to get this in y-intercept form. And how do I do that? Well, I solve for y. I have to get it in the form y equals mx plus b, where m tells me my slope and b tells me my y-intercept. So let's go ahead and solve for y. What's the first thing I want to do? I want to go ahead and move 3x to the other side of my equation. Remember, we're trying to get y all by itself. We need to isolate our y. That gives me negative 4y equals negative 3x plus 12. Now to get y by itself, I need to divide both sides by negative 4. That leaves me with y equals negative 3 divided by negative 4. That's going to give me a positive 3/4. And then 12 divided by negative 4 gives me a negative 3. Because negative 3 times negative 4 is 12. So I have my equation in slope-intercept form. My slope is going to be the coefficient on my x, which is 3/4. And my y-intercept is going to be negative 3. That's all this problem is asking you to do. You don't have to graph it. Feel free to sketch it out if you want to make sure you're doing things okay, but that's not necessary in this problem. Okay, I want to find the domain and the range of this function, y equals negative absolute value of x plus 6. So we should probably sketch this out, okay? Remember when we're graphing functions, if we add outside, that causes our graph to shift up or down. And if we add or subtract inside our grouping symbol, that causes my graph to move left or right. So let's go ahead and graph this. This has a negative coefficient, leading coefficient, so I can already tell my graph is going to be upside down. So whereas normally absolute value graphs open up, this graph is going to open down. So let's take a look at what happens when x is negative 1, 0, and 1. So if x is negative 1, I have negative, the absolute value of negative 1, I'm going to draw my ones like this, plus 6. Well, the absolute value of negative 1 is 1, so I get negative 1 plus 6, which is 5. If x is 0, I'm just going to be left with 6, and this is symmetrical, right? So if I have the absolute value of positive 1, that's going to be plus 6. That gives me negative 1 plus 6, which is 5. So let's go ahead and graph this. I'm going to go ahead and graph this in orange. Feeling very orange today. Okay, so let me graph my points. When x is negative 1, because that's a negative 3. When x is negative 1, y is 5. When x is 0, y is 6. And when x is negative 3, negative 1, y is positive 1. When x is positive 1, y is 5. So my graph, I even missed the point. Darn it. My graph's going to look like this. And I want to know what my domain and range are. Now note, you didn't have to sketch this as precisely as I did. You could just make a rough little sketch. But let's look at what my domain and my range are. So what's my domain? My domain is all possible x values. So in this case, my domain goes from negative infinity to positive infinity. My range goes from down here, right? My range, it's down here. Goes from negative infinity all the way up to 6, and 6 is a closed dot. So 6 is included. So here's the domain and the range of my function.